All right, today we're putting a real titan of the energy world on the stand. I'm talking about the fuel that heats our homes and powers our grid, and yet it's one of the most contested players in the whole climate debate. Yep, we're talking about natural gas. And in this explainer, it's time for a judgment. This quote just nails the central problem, doesn't it? On one hand, you've got this incredibly clean burning fuel, but on the other, well, at the end of the day, it's still a fossil fuel with all the baggage that comes with it. This split personality is what makes it so fascinating and, honestly, so controversial. So this is the big question we're tackling today. Is natural gas that essential stepping stone we absolutely need to get away from coal and oil on our way to a renewable future? Or is it just a dangerous detour, a kind of climate trap that locks us into fossil fuel infrastructure for decades when we should be moving on? To really figure that out, we have to look back. We need to understand how this invisible gas became so fundamental to everything we do. We got to start with its origin story. It's a pretty incredible story of innovation. It all starts way back around 200 BCE, with some clever engineers in ancient China using bamboo to pipe gas right out of the earth. Wild, right? Fast forward to 1821 in New York, and we get the first commercial well. But the real game changers? That came in the 1950s, with massive pipeline networks spreading across continents. And then, of course, the fracking revolution in the 2000s, which completely redrew the world's energy map. Now you've got these giant tankers carrying liquefied natural gas, or LNG, making it a truly global commodity. So let's start by building the case for natural gas. Why did it get so dominant in the first place? What are the arguments that made it the absolute backbone of so many energy systems around the world? Okay, let's just start with how useful it is. First off, it packs a serious punch, way more energy per kilogram than coal. Second, it burns incredibly clean. You know that blue flame on your gas stove? That's a sign of really efficient combustion with hardly any soot. And its versatility is just off the charts. We use it for electricity, heat, making chemicals, even transportation. It's like the multi-tool of the energy world. And this right here, this is the killer argument in its favor. When you generate power, natural gas releases roughly half the carbon dioxide that coal does. This is the single biggest reason it's championed as a bridge fuel. It gives us a direct, scalable way to slash emissions by replacing its much dirtier fossil fuel cousin. So what are we actually talking about here, chemically? Well, natural gas is mostly methane, CH4. It's this simple little molecule that we have to pull from deep underground. Once we get it, it's either moved through these huge pipeline networks or super chilled into a liquid so we can ship it across oceans. Okay, we've heard the defense. It's compelling. But now let's turn to the case against, because the story here is not nearly as clean as that blue flame suggests. And the arguments against it, they are powerful. You've got serious environmental concerns about fracking, the fact that it's a finite resource, and yeah, burning it still releases CO2. But the single biggest problem, the one that really dominates this whole debate, is the issue of methane leaks. This number changes everything. Methane is an incredibly powerful greenhouse gas. Over a 20-year period, 1 ton of methane will trap over 80 times more heat than a ton of CO2. So what does that mean? It means even small leaks from wells, pipes, and processing plants can have a massive climate impact, potentially wiping out that emissions advantage it has over coal. This is its Achilles heel. And this chart really shows you why this debate matters so much. Natural gas isn't some niche player. It's woven into the fabric of our world. About 40% for electricity, 30% for heat. It's so deeply embedded in our economy that trying to untangle ourselves from it is a monumental challenge. All right, the evidence is in. We've heard the arguments for, we've heard the arguments against. Now it's time to weigh it all, score it across our criteria, and deliver the final verdict. So let's look at the scorecard. Its historical impact is just undeniable, a solid 9 out of 10. It is the modern energy backbone. Its properties are great, but those critical methane leaks, they knock it down to an 8.5. It scores really high on workability and versatility, but lasting relevance, that's the big question mark. With peak demand probably on the horizon, we're going to give it a 7.5. And so the verdict is in. Natural gas lands squarely in the high A tier. Look, it's not a perfect S tier forever solution, but its role as the indispensable bridge fuel that helped us start moving away from coal is just too significant to ignore. So why not the top S tier? Well, because the methane leaks and the fact that it's a finite fossil fuel mean it can never be the final answer. But why isn't it B tier or lower? Because its ability to replace coal at a massive scale and its incredible versatility make it far too important to our energy system right now. It is the definition of a powerful but temporary solution. This really says it all. It wasn't the fuel that started the Industrial Revolution, and it's not going to be the fuel that powers the distant future. But it is the essential link between those two eras. It truly is the fuel of the Great Transition. And that leaves us with one last big thought. A bridge isn't a destination, right? It's something you cross to get somewhere else. So, as we stand on this natural gas bridge today, the crucial question we all have to answer is, what are we building on the other side, and how fast can we get there?